Okay. Yes, the question is biofuels, are they good or they're bad? And this has been debated for several years now, and the opinion is quite different between different persons and actors. And I will say that the short answer is that it could be both, of course. We can produce good biofuels and we can produce bad biofuels. But we have quite good knowledge today how to produce the good ones and how to avoid the bad ones. So I will try to describe how this development has been and the findings that we have today. And we can see three clear trends today in biofuel production. The first one is that we need to produce the feedstock in a sustainable way. And for that we have developed standardization systems, both in Europe and internationally in ISO standards. And the second thing is that we should go for systems that minimize the competition of land, so we can avoid the indirect land use changes, which could be negative, that we have to cultivate new kind of land, replace for food production, which are replaced by biofuel production, and thereby increase the emissions from the vegetation or from the soil. And the third one is that we should maximize the output of high-value products from the biomass. We should not only produce biofuels, we should also produce high-value chemicals, or in combination with heat and electricity also, so we develop those very efficient biorefinery systems. So those are the three main trends today that we can see. And if we start to talk about the sustainable production of biomass, we have those two standardization systems I was talking about, the European and the international. And the European is mainly focused on greenhouse gas performance and the biodiversity, that we should avoid using land with high biodiversity, and the biofuels produced should have a good greenhouse gas performance when we look at the total chain from well to wheel perspective. And the third one is the issue about indirect land use. And this is a very tough, hard question. There are quite different opinions about this, and the Commission have not still decided if we should include this in the standard or not. So we will see. And I will come back to that and show that this will have a significant potential of the greenhouse gas performance of biofuels. If we then look at the ISO standard, the global standard now developed, we can see that we here include much more criteria. We have from the soil management and water management and residues, waste, and also socio-economic issues, which could be especially important when we develop production system in developing countries. So this is a work going on, and we have already the EU standard in place, and so we can see that the biofuels that we use today fulfill the criteria regarding greenhouse gases and biodiversity. And hopefully in a few years we will have this standard, ISO standard, which include even more criteria here. And when we try to compare biofuels, the greenhouse gas performance between biofuels and petrol, diesel, and other fossil fuel vehicles, we can see this graph show that the performance depends on how you produce it. You see ethanol production chains in the middle, and the dark blue part of the bars represent the direct emissions, the emissions that we have when we produce the biofuel from cultivation, conversion. And then we have the light blue part. This represents estimations of this ILUC effect, indirect land use effect. And there are different estimations showing very low, and there are others showing very high. But this is some estimations that are which are now included in the European discussion about the level of these ILUC factors. And on the right, you have biodiesel from different kind of feedstock, from rapeseed, palm oil, etc. And you can see that here is the ILUC effects estimated to be higher. And then we can compare the figures here, the emissions, with the fossil alternatives, with petrol and diesel today. And you can see that ethanol is quite good. You can have a quite high reduction of the emissions. For biodiesel from those sources is a little bit questionable. But we have good options here if we use forest residues or lignocellulosic biomass, etc., where we have thermal gasification and producing, for example, FT diesel here. But you can also see on regarding the fossil fuels that we in the future might have much higher greenhouse gas emissions from those, especially if we start to use coal and make liquid fuels from coal, or other new fossil resources that we can be used for this production, not only oil. And we can also have natural gas and make liquid fuels from this resource. So we must compare the actual development of fossil fuels, which could lead to much higher emissions in the future, compare with the biofuels that we have today, even when we include a potential ILUC effect. Another very important issue or trend today is to talk about this low indirect impact biofuels, because we have different approaches here that we can avoid or minimize the risk of this ILUC effect. The first one is that we can actually increase the intensity in the production of biomass from our arable land that we have today. Some land is used not very efficiently, that we can actually increase without having any negative environmental effects. So we can produce more on the same amount of land. The second thing is that we should use residues, waste, etc. in a more efficient way. And a lot of these waste and residues are not used today at all. And the third way is to expand the production on land not used for crop production or food production. Sometimes we call it marginal land, but it could also be more traditional arable land that is not used today. And there is also significant potential that we could use this kind of land for purposes like energy production. And of course, we shouldn't go for the last one, where we expand on existing cropland that we actually use today, because then we have a high risk of this indirect effects. But we have other ways to avoid this negative effect here. And today, biogas is seen as a very good biofuel, which have a very good greenhouse gas performance. And I will just show here some calculations about the greenhouse gas performance of biofuels, biogas based on different kind of wastes. It's food waste or industrial waste, and also manure, liquid manure from agriculture. And compare it with ethanol in this case, and you can see that in this case we have more than 100% reduction, which could seem a little bit strange to say that. But then we have included the indirect effects of using, for example, liquid manure for biogas production. Because when you store liquid manure, you have emissions of methane, and when you use the manure in biogas plants, then you can avoid the emission of methane from conventional storage. So you can say that you have a double climate benefit when you use manure for biogas. For example, this is the main reason why the politicians in Sweden love biogas, talk a lot about biogas and try to promote it, could be promoted even more. But this is a very good solution about biogas. But then, how much could we produce? How much residues waste do we have? And this slide show estimations for the global potential of residues and waste. It's 4 different surveys here, and a conclusion here is that something like equivalent to 10 to 20% of the global energy supply, that amount could we find in residues and waste. And some part of these residues and waste could be used for example, biogas production. So it could be significant, but of course it could not replace all the fossil fuels we are used today. Another thing is the importance of a high conversion systems when we use the feedstock, the biomass feedstock. Today, when we talk about cellulosic biomass, like forest fuels or straw, for example, often used in heat and power production, we can say that those systems have very high efficiency. But then we can see that if we start to develop those systems even further and produce also biofuels, we can still have a very high total efficiency in this system. So we can produce ethanol, biogas, electricity, and heat in a very efficient way, around 70% at least. And also, if we want to go for just biofuels, we can produce, for example, ethanol and biogas also in a very efficient way from cellulosic biomass in this case. And if we look at the research and development today, it's very much focused on the technology, biotechnology in the case of biogas, ethanol, etc., but also new technologies, thermal gasification when we're talking about methanol, methane, hydrogen, etc. And so there is still a significant innovation potential developing those technologies, and also to integrate this process integration in these biorefineries that I was talking about. But if we look a little bit longer, we can see that there is maybe even a higher potential of innovation in implementing those technologies, for example, by integration between different industries. So it must be a new kind of cooperation between the energy, the oil companies, energy industries, oil companies, forest industry, chemical industries, etc., to really develop those very efficient systems, and also use the infrastructure that we have. For example, if we have a district heating system, that this system could be used also in this development here. And also in totally new business solutions, that we have different kind of branches that will start to cooperate, so which have never been cooperated before. So how to develop those business solutions are also very important in an innovation perspective here. And finally, we of course must use the biofuels in the most efficient way. And this slide here show how long transportation distance you can deliver by 1 unit of biomass if you make a biofuel and use it in a conventional car that we have today. Compare if you use it for electricity and use it in a pure electric car. And then you can say that the electric car is around 3 times more efficient than the biofuel car. So the conclusion from this is that we must use the biofuel much more efficient. For example, if we develop a hybrid car, electric hybrid cars, fueled by biofuels, biogas, ethanol, different kind. And if we look at that and also develop plug-in hybrid cars fueled with ethanol or biogas, we can see that the total efficiency for the complete chain is almost the same as electric cars. There is not that big difference then. So, back to the question, what is sustainable biofuels? Well, sustainable biofuels are those produced from organic waste and residues, like biogas. It fulfills almost all the sustainability criteria that we have today. But we have also sustainable biofuels from annual crops. If we use excess cropland, if we don't have this eye-look effect, we can see that today. We call that first generation of biofuels. We can show that some of those systems are quite efficient. And then we have the perennial crops, cellulosic crops, that could be grown on excess cropland, but also on what I was talking about, this marginal land that we might have quite a lot of. And then we have also indirect benefits from this. We can increase the soil carbon content, for example, and also this biomass could be used for ethanol, but also gasification and methanol, hydrogen, etc. And we must produce the biofuels in the most efficient way, and we see the trend now is develop this biorefinery concept that we produce those together with heat, electricity, and also biochemicals, etc. And finally, use the biofuels in very efficient car, and here we have a very good way to do that by using them in hybrid electric cars. Okay, thank you for your attention.